prove that d by dx of f of x plus g of x equals the derivative of f of x plus the derivative of g of x, where f and g are both differentiable functions. In other words, the derivative of the sum is the sum of the derivatives. Okay, so to prove this, we're going to need an expression for this f of x plus g of x here. So let's pick a letter. How about s of x? We'll let s of x be the sum of f of x plus g of x. And now I can write the limit definition of the derivative in terms of s of x. So I have the limit as h approaches 0 of s of x plus h minus s of x all over h. And now I can plug in. So s of x is f of x plus g of x, so s of x plus h should be f of x plus h plus g of x plus h. Okay, minus, and then we have s of x, which is f of x plus g of x. And then all of this is over h. Okay, so the goal here is to get this as two separate limits, one with f of x and one with g of x. So I think you might see how you could break this apart. Let's kind of group the f of x stuff together. So we have f of x plus h, and then we're going to have minus f of x. So that's one thing we'll group together. Plus, and then we'll group the g of x stuff together. So we have g of x plus h minus g of x. And all of this is over h. And now I think it's pretty clear what's going to happen. We can break this into two separate limits. This is really the limit of f of x plus h minus f of x over h plus the limit as h approaches 0 of g of x plus h minus g of x over h. This is the derivative of f of x. And the second term here, that's the derivative of g of x, and that's what we were trying to prove.